So it's also my great excitement and privilege to talk to you about the recent developments in diffusion MRI on the NexGen 7T. This talk's going to give you the foundation for all of the subsequent exciting phenomenal diffusion work that you're going to see later today. So you heard a lot about the NexGen already, but I wanted to just highlight how even though the Gmax and slew rate are much better than what you get on the standard 7T, when you factor them both in together, it's really over a magnitude more powerful than the standard 7T gradients. And that means a lot for when it comes to diffusion. So what does that, how to get a better intuition for those who are not familiar with diffusion? Here I'm showing a pulse sequence diagram highlighting how on a standard 7T, the diffusion gradients are quite long, like they're about as long as your entire readout of your images. And that's not great because then the the TE gets really long, you get signal decay, makes it really hard to get good diffusion. But with the NexGen 7T, with its impulse gradients, you can cut that imaging diffusion encoding down in half, more or less. And that allows you to get faster scan times, less T2 blurring. You get earlier TEs for higher SNR, and you can trade that higher SNR for higher B values and also higher resolution. So I like to share this slide also right after because it highlights the type of protocols that people are asking for in our collaboration. So what can you do with this scanner in about 15 minutes for diffusion? Compared to the HCP or HCP-like diffusion protocol from the first Gen 7T, we were at about 1.25 millimeter isotropic. But with the next Gen 7T, you can cut the TE and TR down quite a bit and get the resolution down to almost a third, which is phenomenal, all in the same amount of time. And so you can get these really nice whole brain diffusion images. Thanks to the new RF coils from Xiaozhang Grimoni, you can see we even get good B1 homogeneity in the cerebellum, which is pretty hard for the standard Nova coil. Here I'm showing all three cross sections, so you can really get a sense of how good the whole brain coverage can be. The diffusion looks really great, even for just this 15-minute protocol. If you have a bit more time, let's say 30 minutes, you can do a bit more advanced modeling with multi-shell encoding. And in collaboration with Peter Basser's group, we show here the fiber orientation distributions that you can get both in white matter and gray matter. And this is important to note because usually when you do diffusion, you kind of, for standard 3T resolutions, you kind of ignore gray matter most of the time. But now this opens up the possibility for gray matter-based, seed-based connectivity in diffusion and all kinds of cool things like laminar depth-dependent diffusion. And you can use this really depth of information that we get from the NexGen to do really cool fiber tracks maps, thanks to Kurt Schilling, who's here today also. And you can see on the left, you can get really nice fiber track maps that go all the way to the cortex. And if you focus on the white matter, on the right, you can see lots of U fibers that are typically hard to see in a standard 3T protocol. So this is kind of the high res side. And for the sake of time, we couldn't push the resolution even higher, but I'll save that for others to talk about later. But for this next slide, I want to talk about, instead of pushing the spatial resolution, what if we, step back a bit from spatial resolution and focus on angular resolution, or in other words, the ultra high B values. So here I'm showing on the top, it's for the next Gen 7T where we acquire B value of 10,000, 20, 30, 40, and compared to what you would get if you do that same experiment on a standard 7T. And you can see, thanks to the much shorter echo times that we can achieve, the SNR gain grows dramatically as a function of the B value. So here with the 10,000, you get threefold higher SNR, 4, 6, 8 for these really unheard of B values that you almost never use. So this is really exciting. It'll open up new scientific hypotheses for people to use these ultra high B values and see what we can get. Of course, with this surplus of SNR, you can also go to higher resolution. So here I show what those images look like if you cut those blocks of volumes in half, and you still get like much more signal than on Lutera. So it's really exciting what we can do with this. Okay. So I want to switch gears a little bit for this later part of second half of it. And that is a common question that people have is, should I use 3T or 7T for diffusion imaging? And, for a long time, people have known 3T for its ability to get super strong gradients like the Prisma or the Connectome scanner. And so there's a lot of good reasons to do it on 3T. It has homogeneous U1 fields, lower SAR, so you can do more multiband, scan faster. You have longer white matter T2, so better SNR performance. And yeah, it's easier to put strong gradients into lower fields. But with the NexGen 7T, there's a lot to think about doing diffusion at 7T. So if you look at how SNR is super linear with field strength, and if you get to the ultimate intrinsic SNR, you could get upwards of like 5 times greater SNR at 7T. And you can trade that for smaller voxels to do really high resolution. And then also if you factor in the new gradients that are available on the NexGen 7T and the new RF coils and PTX improvements, diffusion starts to look really attractive at 7T. Okay, so I'll wrap up as soon as possible. So here is using all of those benefits that I just talked about, that's in the new 7T system. I plot here, on y-axis is SNR, x-axis is different B values, and we wanted to see like how does it compare to the latest and greatest 3T systems and the first generation 7T. And you can see that thanks to the higher field strength and superlinear gains in SNR relative to field strength, even with the shorter T2s at 7T, we get substantially higher SNR gains compared to the Connectome 1 and the Connectome 2. So we're really excited about what this scanner can achieve for the diffusion imaging community. So here's a few examples of what you can do. We thankfully MGH with their Connectome 2 came out with this Nature paper last year, and we wanted to see, well, how does our p-value of 40,000 look compared to those? So we scanned similar subjects, found a similar slice, and you can see that at those p-values with similar whole brain coverage at similar 2 millimeter isotopic resolution, we get much more SNR, at least in our hands in this, qualitative comparison. So we're really excited about what this might mean and how we can further collaborate with the MGH group on their Connectome 2 to compare more in depth. But I wanted to also show this as a teaser for, this is my last data slide, but what you can use these ultra-high B values for and what information it contains. Here I'm showing on the left, it's a very traditional, primary diffusion or direction, primary fiber direction map, and you see the standard fibers that you expect. But what you want to see with these higher B values is, can you pull out these crossing fibers? Because we know that the brain is more complicated than just single fibers crossing around. So in blue here, I'm plotting the secondary crossing fiber. So that means the most prominent secondary fiber. Red is the third crossing fiber, and green is something that people never bother to model because they never had enough data to do it, but now we can. So this is the fourth order crossing fiber. And you can see with the standard B value 2500 max, you can get plenty of secondary crossing fibers and some third order, but almost no fourth order crossing fibers. But when you take advantage of the NexGen 7T to get these higher and higher B values, you can see that you can pull out this really cool information. You could probably get fifth order crossing fibers. I just haven't put that in the model yet, but this just gives you a flavor of how much information that you can get and how much SNR is available even at this 1.6 whole brain resolution. So key takeaways, I would say in the NexGen 7T is arguably the best scanner for diffusion MRI right now. It provides transformative reductions in TE and gains in SNR for higher spatial temporal resolution diffusion imaging, ultra-high B values, high angular resolution diffusion, and I'm really excited about the diffusion presentations that we're going to see today. One caveat you may have noticed, some parts of the cerebellum have slightly less U1 homogeneity, but I think with PTX, and we'll address those in the near future. So if you want more details or want to collaborate on our scanner, here's the email address, and I think everyone knows. But thank you very much for your attention.